All right. So let's have the question answers now as we proceed. Why is it not moving? Yeah, I think it has started moving. All right. So this is going to be the first question. Given the IP address and subnet mask of X and Y, okay, IP address is given, subnet mask is given. Which of the following would describe this address? All right. So you are given an IP address and you are given a subnet mask. You are asked to find out what is the nature of this address. Is it a usable host address, or is it a broadcast address, or is it a network address, or you want to say no sir, this is not at all a valid IP address. Okay, so in that case, what would be your answer, right? So let me seek the assistance of a notepad. I'll just rewrite these values here. um, I'll keep it here. Okay, so 172.16.134.64. Okay, so this is the IP which is given, and the mask is 255.255.255.224. Okay. There are multiple ways to solve this question, to solve this problem, to find the answer. But how I would do, probably I can explain to you. Now, if you look at the mask, I'm not going to look at the IP address because that is not at all going to help me. Though if you look at the IP address, it is 172.16. You'll be tempted to see that it is a class B address. And you all will be tempted to see, okay, the mask is /16, which means 255.255.00, which is the default mask. And you may start scratching your head how this is all going to happen. These kind of questions probably has to be attacked from the mask value. Okay, so I write the 255.255.255.224. That is the mask value, and I'm trying to figure out how many bits are available with the network portion. How are we going to find out the? All right, so number of bits which are belonging to network has to be identified. Okay, when you say 255, because I'm assuming that you all have worked with these values, kind of values earlier, I'm going to skip all the fundamentals. All right, so you got 255 in the decimal, which means there are 8 bits in the binary, which is in which has the value of 1. And again, you got another 8255, so which means another 8 bits are in binary. Another 255, another 8 bits are in are 1 in binary. Okay, so 24 is for confirmed. It is going to be 255. Now, how can I find out how many bits are with the network when I look at the last value? You may be remembering, all right, there are 8 values, 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 values which have been filled up to get 224. Okay, so initially I'm not going to use all these underscores now, that will waste the time. I make all these as zeros, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to assume that all these bits are 0. It becomes 255, 255, 255, 0. Okay, but what I have is 255, 255, 255, 224. So what am I going to do? I just make it as 1. Now what's the decimal value? If you could help me, 255, 255, 255, 128. You understand? 1 followed by 70 in binary is 128 in decimal. Okay, I go and add another value. Now this is 1, 1 and followed by 6 zeros. This is going to be 192. You got it? How does it come? It is a decimal, binary to decimal conversion, as you all know. All right, so it is 192. So I make another one. This is going to be 224. Okay, 111 followed by 5 zeros is in binary is equivalent to 224 in decimal. Are we getting the same thing? Yeah, we are having same 224, which means 8 bits in 1, 8 bits in 1, 8 bits has 1, and another 3 bits. Okay, so this many bits are available with the network portion. How many? 24 plus 3, 27, which means how many bits are available with the host? Probably I write like this. Oh, no. Okay, this is the network portion. Totally how much? You got 27 bits are with the network portion. So how many are supposed to be the host portion? It's going to be total 32 minus 27. It is equal to 5 bits. So there are 5 bits available with the host portion. You got it? So only 5 bits are available with the host. So what will be the different range of values in the last octet? As you know, 0 to 31, Okay, then 32 to 63, then 64 to 95, and then 96 to 127, then 128 to 128 plus 31, 159. All right, so 160 to 191, then 192 to 223, and then 224 to 255. Okay, so these are the 8 range. When you have, I'll make it little bigger for you to know. All right, so when I have 5 bits available in the host, this is going to be the range of last octet in that IP address. Now your logic is very simple. What the question? You will go back to the question. It says 172.16.134.64. What is it if this is the mask? What we have done so far, if this is the mask, we have identified this is going to be the last octet values of different range. So 0 being the network address, 31 being the broadcast address, 32 is the network address of next subnet, and 63 is the broadcast address of that subnet. The third subnet will have network address 64, broadcast address 95. The next one will have 96 as the network address and 127 as the broadcast address. And the story continues till 255. Right now, where do we have 64? You got 64. Where is it coming? It is coming here. Okay, 64 to 95 is one of the ranges of the IP of the subnets. Okay, now what is 64? As I have just said, it is a network address. Do you have the answer? Usable broadcast. So my answer is going to be C. Oh, no, this is actually a network address. Okay. So whatever is mentioned here, it's wrong. It is a network address because the mask is 224. This is supposed to be the answer. This is a network address. I'm sorry for it. This is a mistake which I have made. All right. If it is 63, have you got? Yeah. If it is 63, this is a broadcast address. Okay. If it is 64, this is going to be a network address. Okay. So the answer is supposed to be C. All right. Similar question. What subnet mask would a network administrator assign to a network address of 172.30.10 if it were possible to have up to 254 hosts? Now again, the question is, let's not look at the IP. Okay, the IP is 172.30.10. Now the question is, sir, what is the subnet mask you need so that you will have 254 hosts? Okay, this is a very simple question to answer. I go for this. I'll take the mask of C. Randomly, I choose C. Okay, 255.255.255.0. Okay, so you got 255.255.255.0. How many bits are available in the network? Okay, it has got network having 24 bits. How many are with the host? Host is having 8 bits. Okay, you have the formula, the number of usable hosts. What is the number of usable hosts? Is 2 power 8 minus 2. I'm sorry, 2 power n minus 2. What is n? N is the number of bits in the host portion. Okay, so when you have 8 bits in the host, so this becomes 2 power 8 minus 2. It's supposed to be like this, 2 power 8 minus 2. Okay, so 2 power 8 is 256. Yeah. 232, 64, 128, 256. Okay, 2 power 8 is 256 minus 2. This is going to be 254. Okay, if the mask is 8, all right, if the number of bits in the host portion is 8 bits, you will be able to get 254 usable hosts. Now let's go back to the question. Fortunately, you are supposed to ask to find out 254 hosts. What is our calculation? We randomly took an IP mask, subnet mask. It's a class C default mask. I understand network portion has got 24 bits and host, not hot. Host portion has got 8 bits, which indicates that 2 power 8 minus 2 is 256 minus 2, indicating 254 is the usable host. So the point is, if this is your default mask, if this is your subnet mask, you'll be able to create 254 usable host address. Now, what's the question? What subnet mask would a network administrator assign to a network address if it were possible to have up to 254 hosts? All right. You have got 254 hosts. What is the mask? 255.255.255.0. Where have we got? You got here, you are supposed to have that as the answer. You got it? Now, what will be the answer if I take 255, 255, 254, just for instance, okay? I don't change it here, probably I'll write it again. Take 255.255.254.0. If it is 254.0, it indicates in the network portion, you got only 23 bits. In the host portion, you have got 9 bits. Why? Because here 1 bit is borrowed and these 8 bits are already with the host. You have already borrowed 1 bit from the network. So it becomes 23 and host is 9 bits. So 9 bits, what is the usable host? It is 2 power 9 minus 2. So what's the answer? It's going to be 512 minus 2. It's going to be 510. All right. So this is the number of usable IP addresses, or this is the number of usable host address in case you chose this IP. Similarly, you can go for this. If it is 248, 255.255.248.0, it indicates with the network. So you got 8 plus 8 plus 248. 248 means another 3 bits are gone. So it is going to be 21. So for the host bit, it's going to be 11. Yes, it's going to be 11 bits. So how many usable hosts? It's going to be 2 power 11 minus 2. So it's going to be 2048 minus 2, 2046. Okay, forgive me if the number is wrong. It's 2 power 11 minus 2. All right. So this is how we are supposed to hit at this answer. So one answer is you took a random value. Fortunately, that worked. Otherwise, you can try to deduce from these numbers. Okay, you can start doing from the answers. Just hold on. Is it okay? So this is how you should hit. You should find the answer for the second question. Okay, moving on. What is the network address of the host? These things in binary. All right. This question will look something strange. How is it going to happen? All these things, but this is going to be very, very easy. All right. There are two things. One is if you look at the first two values, first two octets. Okay, this is 172, 25, 67, 97, 99. Okay, if you look at these two, all have the same prefix. Okay, this is 1010 1100. 0001111. You know, the same thing it is with A, B, C, and D. So that is not going to help you. Let's move towards the third octet. In the third octet also, first 7 bits are same. You got it? First 7 bits are same. So your answer is supposed to be in the remaining 9 bits. You got it? Because all other bits are matching. All other positions are same in all the 4 answers. All right. So look at the remaining 9-bit values. Okay, there we have to find out. Now this says the mask is 23. Okay, so what does it mean, sir? When you have the mask as 23, it says /23. /23 means 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7. Am I right? Because 8 plus 8 plus 7. 8 plus 8, 16 plus 7, 23. Dot 1, 2, 3, 4, 5, 6, 7, 8. So this is the meaning of /23. Okay. When you have /23, this is the meaning. You know this very well. I'm just helping you to recall it. Okay. Now, let's go back to this number. This number says first octets are 10101100. And the second is going to be, second is also same. We have just seen. I'll make it somewhere like this. Okay. So what is the equivalent binary of 25? It says 3 zeros, 11001. Okay. And then 67, it says 01, 00, 1. All right. And this position is supposed to be verified because it is in the mask. Okay. So all the remaining bits are going to be 0. Now the question is, what is the network address? When it is network address, whatever the value here, it is going to be 0. Because your mask has got 0. So this could be 1, this could be 0. That is okay, sir. But this is supposed to be 0 because the mask is going to be 0. So I would go for this as the answer. Do we have this as the answer somewhere? Yeah, so I would prefer the answer as C, but we'll check it up, okay? Because only in C it matches. In B, this becomes 1. So this is the binary equivalent of 67. Okay, what is 67? 0, 64, 32, 16, 8, 4, 2, 1. So this is the binary equivalent of 67. Have you got it? Yeah, it is here. But the question is, what is the network address? When you have got the network address, when you go for AND operation with the subnet mask, this becomes 0. So it is going to be 0, 1 followed by 4 zeros and 1 0. This is going to be the answer in my calculation. Okay, so where is it? That is going to be C. It's not going to be B because all these bits are becoming 1. That is not possible. Here also you got combination of 0, 1, 0, 1. That's not going to be the network address. So the competitor is A and C, but A is the actual IP address of 67. But I would say this is the answer. Okay, so you got it. So this is how you should find out. This is very simple anyway. How can you do that normally? So if you want to just make it very simple, just write down the binary number, binary equivalent of 172. 172 binary equivalent is already given 10101100. And then 25 000 111 67 01 000011 dot 99 0, then 64 plus 32, 64 plus 32 96, then 16 is 0, 8 is 0, 4 is 0, 98 1. Okay, so this is going to be 99. All right, so 64 plus 32 96 plus 1 97 plus 2 99. Okay, now what is the mask? Because it is binary 23. 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7. 23 bits are over. Then all these are going to be 0, 4 5 6 7 8. Now you go for binary AND operation. If you go for binary AND operation, wherever you got 1, you will get the actual value. So 10 10 11 00 0 0 0 11 001 01 0 0 0 0 1. Oh, sorry. 01 0 0 0 0 1, and you got a 0, then it's going to be all 0. So this is going to be the answer. This is another way probably to find out the binary value. So whatever may be the case, you got the third answer, third option as the right answer for this question. Okay. In IPv4 addressing format, the number of networks allowed under class C addresses is in class C. Okay, probably this is going to be very, very straight answer. If you look at class A, the number of networks, it is known to you anyway, and number of hosts. Okay. Similarly, we are going to write it for everyone. This is known to you. So in class A, how many bits are with the network? 7 bits. How many bits are with the host? 24. Okay, the number of networks is 2 power 7. Power 7. Where is 7? Okay. All right. So this is going to be the number of networks in class A. I'm not going to worry about class the number of hosts, because that is not the question. It's asks how many number of networks. So if I calculate this for B, this is going to be 2 power 7, 8 plus 6. 8 plus 6 is 14. For class C, it is 2 power 5 plus 8 plus 8. How much? 21. Okay. So this is going to be the answer. How are you calculating, sir? You would have learned a table in class A. The first octet is going to be 0 followed by the values. Then it is going to be 1 0 followed by 6 bits. Class C, it is 1 0 1 0 0 no 1 1 0 followed by then 1 1 1 0. And in class E, it is going to be 1 1 1 1 followed by 4 zeros. You remember? That is how you got the class A, B, C, D, and E in IPv4 calculations, right? And in class A, first octet is for network, remaining 3 for host. So there are 8 plus 24 bits. The first bit is made as 0, so you got only 2 power 7. I hope you remember all these calculations given by your faculty member, right? So this is a straight answer. You are supposed to know this answer by heart by looking at the number. Okay, this is for class C. Moving on. There is a question. Suppose computers A and B. Okay, there are two computers A and B have IP addresses 10. Okay, we'll write it down somewhere so that it is easy. I keep it here. Yeah, no, I keep it somewhere here. All right. There are two computers. One is A, the other computer is B. All right. So A has got IP address 10.105.1.113. All right. And B has got 10.105.191. Respectively, these two are having this computer, and they both use the same network mask. Okay, they use the same network mask. We do not know what it is. Okay, which of the values of n given below should not be used if A and B should belong to same network? Okay, this is a tricky question. Now the question is, sir, there are two computers, A and B. Okay, so probably like this, A and B are connected, okay, through wire. Now these two are in the same network. Got it? They both use the same subnet mask. Which of the following should not be used if they belong to the same network? All right. So how can we do that? We have to do the method of elimination. So what is the first one? 255.255.255.0. What is this? This is the default mask of class C. So in that case, what is the range of last octet? It is going to be 10.105.1.0 to 10.105.1.255. This is going to be the range if I use this as the mask. Why, sir? It is a default class C mask, but this IP is class A, but it is subnetted by borrowing 16 bits. That's the meaning. So 16 bits have been borrowed, and you will end up in getting 0 to 255. This is the whole range. What is our IP? Our IP is 113 and 91. Where are they? Yeah. Do you think this 91 and 113 is in this range? 0 to 255? Yes, 0 to 255. So 91 and 113 are the numbers featuring between 0 and 255. So that mask can be used. All right. Second one, 255.255.255.128. If this is the mask, what has happened? One bit has been borrowed. So what will be your IP address? It is either 10.105.1.0 to 10.105.1.127 is one range. Another range is 10.105.1.128 to 10.105.1.255. This is the second range. Okay. Now, where have you got 91 and 113? It is well falling in this range because the last octet is 0 to 127. Your number is 91 to 113. So 91 to 113 is exactly available here. So this mask also can be used. So I just say okay. Means that is not the right answer for this question. Okay, that also can be used because the question is which of the values and given should not be used. Okay, so we are going to find out which is not working. Now next is 255.255.255.192. Okay, what is the meaning of 192? You have borrowed 3 bits. So in order to save the timing, I'm going to write only the last octet value. So last octet will become 0 to 63, then 64 to 127, then 128 to 191, and then 192 to 255. This is going to be the range. Okay, now let's go back to our number. Our number is 11391. Do you have 11391? Yes. 91 to 113 is falling in this range. I have written only the last octet. Okay, instead of writing 10.105.1, I have just written this to save time. So the number which is given is 91 and 113. That is again falling in this range. So for me, this mask also can be used. Okay. Now, okay, the last answer is supposed to be the right answer for this question, but we'll verify it. 224. When it is 224, you have borrowed 4 bits. Okay, when you have borrowed 4 bits, the range is going to be, I think I have written somewhere in the initial, yeah, right, when you borrow 4 bits. I copy this. You see this? 224. If the mask is 224, you will have this range. All right. Now you have got 2 IP addresses. What are those? 91 and 113. Where is 91 and 113? Yeah, could you see 91 is in this range, 64 to 95. So 91 is here, 113 is between 96 and 127. Do you understand what I'm trying to say? Yeah, these two are in these separate networks. Okay, 91 is here, 113 is here. So I cannot use this mask. Have you got it? All right. So for me, if the question is asked to me, I will say that 255, 255, 255, 224 cannot be used. Which of the following should not be used? I would say 224. Hope I have convinced you that that's going to be the answer. Is it okay? Fine. Moving on. Yeah, router interface. This is the next question. These all are only, we are talking only about the IP addresses. Okay. A router interface has been assigned an IP address of 172.16 some XY with the mask of something. To which subnet does the IP address belong to? Sir, this is again a question of subnet masking. Okay, this router, IP, all these are just to confuse you. The question is, the meaning of the question is, sir, what is the network, what is the mask? Okay, what is the subnet address for this IP? That is the question. How will you find out the subnet address? You have got the mask. Mask is 248, which means 5 bits have been borrowed. Am I right? Yeah, 6 bits, 7 bits, 8 bits. Yeah, 5 bits have been borrowed. So what will happen in the last octet? You got only 3 bits. So 0 to 7. Okay. So 8 to 15, 16 to 23. Okay. Then 24 to 31. It will go like this. Okay. Somewhere we will reach this 128, 159. Okay. Then it's going to be 160 to 167. Then 168 to 175. Okay. So like that, this will go. Right. So you should have the patience to write this number. Sir, very simple, sir. Because it is 248, 255. 255 minus 248. It's going to be 7. Am I right? Yes, it's going to be 7. Yes, it's 7, which means 256 is the last number. So you can think of having a range of 8, 0 to 8, 0 to 7. So there will be 8 numbers. So you will write 0 to 7, then 8 to 15. On all the left hand side, you will add 8888, and the right hand side, you will add 8888. So we'll get this range. And eventually, somewhere you will get something like this. Okay, something to 127, then 128 to 159, and so on. At 128 to 159, this is going to be 152 to 159. Okay, like that. Okay. So you will be having range like this, but as you are calculating this way, you will reach a line like this. It is 160 to 167. Okay. Or should I talk about 160 to 167? Because you got 166. Why? That's a question. 166. Where is 166? It is here. What is this range actually? 160, 161, 162, 163, 164, 165, 166, and 167. So this is going to be the range of this. Where is 166? It is here. Where is it? It is here. All right. So what is the network address? The first IP. So what is that value? 172, 16, 192, 160. Where is it? 172, 16, 192, 160. So my question is, to which subnet does the IP belong to? It is not belonging to this. because the mask is very bigger. It is not belonging to this and this. This is going to be 128. Is it okay? I'm sorry, it's going to be 160. That's the last value. All right. So this is how we should find answer for this. See, all these questions are only to find out the network address, the broadcast address, the usable host address by giving the IP address and the mask and so on. Okay. The question may have different flavor. Okay. Here they have spoken about the router interface. Somewhere else they may talk about two computers are connected. What is the mask? So you should understand the meaning of the question before you start answering. Okay. Again, another similar question. If a class B network on the internet has a mask of this, sir, this class B is here just to confuse you. Okay. The question is, there is a mask of 255.255.2480. What is 255.255.2480? I write like that. 255.255.248.0. Okay, that's what I just returned the mask which is given on this screen. What is the maximum number of hosts per subnet? How can you find out? You need to find out how many bits are available in the host. If n bits are available, you will just say 2 power n minus 2. All right. All you need to find out is how many bits are with the host. How can I find out? It is 32 minus number of bits with the network. You know that. Okay. So how many bits are with the network? 255 means 1, 2, 3, 4, 5, 6, 7, 8 in binary. 255, 1, 2, 3, 4, 5, 6, 7, 8. 248, 1, 2, 3, 4, 5. Yeah. And then if I add another one, okay. So this is 128, 192, 224, then 240, then 248. Dot 0000000. This is the actual binary representation. We'll just confirm this because I am comfortable with first and two. The third one, this is 128 plus 64, 192 plus 32, 224 plus 16, 240 plus 8, 248. Okay, so this is the binary value. So how many bits are with the host? 8 plus 3, 8, 9, 10, 11. So there are 11 bits are with the host. So how can I find out the number of hosts per subnet? Simple, sir. It is 2 power 11 minus 2. If it is n, it is 2 power n minus 2. So 2 power 11 is 2048 minus 2, 2046. You got the answer? Yes, you got the answer in C. So this is going to be the answer for this question. Okay, 2046. This is a very simple question for you. You can easily have a walkthrough on that. All right. Simple. Another interesting question. Which of the following IP address can be used in WAN? This seems to be tricky, but it's a straightforward question. The meaning of the question is, what is the public IP? You got it. Which of the following is the public IP is the question. What is public IP, sir? Because public IP are the IP addresses which can be routed over the internet. So when you are talking about the wide area network, you are supposed to use the public IP. You cannot use the private IP. We all know that. Okay. What is that private IP? The private IP addresses can be used within a LAN for your local connectivity. You got it? Okay. This is just to combat with the IPv4 address depletion. All right. That's the reason we go for IP, the private IP concept in the IPv4. Okay. So which of the following can be used? The meaning of the question is, which of the following is the public IP? Okay. So 10.0 private IP, 172.16 private IP, 192.168 private IP, 15.1 is not a private IP, so it's supposed to be answer C. Okay, so question is, which of the following is the public IP? Do you have time? Yeah, I have another 5 minutes. Okay, which of the following can be used as both source and destination IP? This is little tricky. Okay, now we have to find out which of the following is a valid IP address. Okay, so how am I going to find out which is the valid IP address? Okay, 198.168.1.255 seems to be valid IP. Okay, then 10.0.0.1, yes, 127.0.0.1, yeah, it is also a valid IP address. 255.255.255.255, again all 255s. Okay, seems to be a good IP. Now we have to be careful with this kind of question. Which of the following can be used as both source and the destination IP? Okay, an IP which can be used as the source IP. Similarly, the same IP can be used somewhere as the destination IP also. Doesn't mean in parallel, but it is valid. It can be used as both, as source. Maybe in some other occasion, it can be used as destination. Okay. So let's look at what these IPs are. Then only we can find the answer for this question. Okay. First one is 198.168.1.255. Now, what is this IP? Is it a valid IP? It is a valid IP. How do you say that it's a valid IP? Because every of the octet value is ranging from 0 to 255. Yes, every number is between 0 and 255, including 0 to 255, of course. All right, it is valid. It seems to be valid. Then what's the problem with this IP? Okay, so we'll say that this is a class C IP, right? Mask is not given, so it is a class C IP with the default mask. What is the default mask? 255.255.255.0. Okay, when the mask is 0, what will be the range? 198.168.1.0 to 198.168.1.255. So what? Look at this number, 198.168.1.255. What is this? I have seen this here. What is this problem? Yeah, do you remember? This is a broadcast address. Okay, this is a network address. Generally, this is called limited broadcast address. Okay. What is this broadcast address, sir? Can we use this IP? You can use this IP only as the destination IP. This IP cannot be used as the source IP. Okay, this IP cannot be used to assign, cannot be assigned to any machine. Similarly, 1.0, which is a network address. Okay, so in my understanding, the first one is already ruled out because it is a broadcast IP which cannot be used as source and destination. It can be used as destination IP if you want to send a limited broadcast message or a controlled broadcast message to your local area network. So first answer is ruled out. Second is 10.0.0.1. What is this IP? This is a valid IP for me. It is a class A IP, and this is also a private, class A private, because it is 10.0. Can this be used? For me, it can be used, but anyway, we look at the remaining two and come back. The third one is 127.0.0.1. What is 127.0.0.1? Yes, you are right. This is called loopback IP. Okay, this loopback IPs are generally used for various reasons. One of the reasons is to check whether your TCP IP stack is properly installed. Okay, in case you are not able to ping other machine in your network, you can ping 127.0.0.1. If it is pinging, your machine has got the excellent TCP IP protocol stack installed. Otherwise, there is a problem with your operating system and the related services. And this also can be used in the routers interface, which are called as loopback interfaces. This is to simulate and scan, and also to measure the performance of your routing algorithms. All right. So 127.0.0.1 cannot be a source IP. It can be a destination IP, which is not existing, but it is a loopback IP. So that is ruled out. As of now, second seems to be right. What is this 255.255.255.255? This is called a broadcast address. The last IP, the final IP of your IPv4 stream. What is this here? This everything 0 is used in your default static routing. If you know that IP route 0000, you know that IP address, right? So that also cannot be assigned. All 255s also cannot be assigned to your machine as the source, but it can be used as destination. So I would go for 10.0.0.0.1 private that can be used. This cannot be used because it's a limited broadcast address. This cannot be used because it's a loopback IP. This is a broadcast IP. So my answer would be with B. All right. So I stopped my sharing here, and I also stopped recording.